Nuclear power plants have the same inherent risks as other power plants. All power stations are generating a lot of heat in order to turn turbines which make electricity. It is this heat and its confinement which is very dangerous. A nuclear power station is as safe, if not safer, than any other type of power station. The problem with nuclear comes when things go wrong. If there is an accident at a coal-burning power station, then the relevant authorities can get into the power plant and deal with it. The worst that will happen is that the coal station can blow up and leave a big dust cloud in its place. The same is true for a nuclear power station, except the dust cloud would be far larger and radioactive. The aftermath of an accident at a nuclear power station, due to the nature of radioactive material, will take considerably longer to deal with than any other form of power production. But without a catastrophic failure, there are lots of other safety issues to be addressed that are solely the issues of nuclear power generation. Firstly, there is the fuel that a nuclear power station uses. Nuclear fission can be performed by one of two elements. The first is uranium-235. This is naturally occurring, if rare, and needs extensive processing in order to get it from the mine to the power plant. Even when in the power plant, the concentrations of uranium-235 in the fuel are so low they cannot be turned into an explosive device. However, uranium-235 is radioactive from mining to the power plant, and so needs to be specially handled. Just because the concentration of uranium-235 is too low for a nuclear weapon, doesn't mean that it can't be used in a dirty bomb and contaminate an area with low-level nuclear materials for hundreds of years. Safety considerations need to be taken into account there. The second possible fuel is a byproduct of fast breeder reactors and can be used in nuclear weapons. This is plutonium. The advantage of using a nuclear reactor that will make plutonium is it extends the life of the world's uranium store. It takes uranium and makes plutonium, thus manufacturing a fuel for another nuclear reactor at the same time as making electricity for consumers. The obvious problems with the fuels used in nuclear power generation is their radioactivity and possible proliferation of nuclear weapons. The next problem with using nuclear fuels is the protection of all those people who work at the nuclear power station and the surrounding areas. Nuclear power stations produce radioactive byproducts, which need to be stored on site. The reaction itself also generates considerable amounts of radioactivity. This radioactivity in high enough doses can kill people, and even in low doses increases the likelihood of people to suffer cancer in the future. For this reason, nuclear power stations employ two techniques. One minimizes the amount of radiation an employee is exposed to, and the other monitors the exposure left over. The minimizing of radiation exposure is done using shielding. The best shield to radiation is distance, as radiation intensity is the inverse square of distance from a source. However, in places where there is not a lot of space, the shielding depends on what sort of radiation you are dealing with. If you are shielding from gamma radiation, then lead is your best option. Its density means that you can reduce the intensity of gamma radiation in a short thickness. However, if you are trying to shield from neutron radiation, you do not necessarily need lead. You can use water to reduce the exposure, as this absorbs and deflects neutrons, making them less energetic and therefore less dangerous. Even with this shielding, you need to monitor your employees to see how much radiation they have been exposed to. This is done using film badges similar to X-ray film used at hospitals. These tell you the cumulative amount of radiation an employee has been exposed to during the wearing of their badge. The final problem to protect against is that of catastrophic reactor failure. The biggest problem inside a nuclear reactor is heat generation. The nuclear reactor does not contain uranium in a high enough concentration to go critical, but it does contain enough uranium to generate a large amount of heat. The heat inside the nuclear reactor, if left unchecked, can be hot enough to melt the containers holding the fuels and the fuel itself, making it impossible to contain the nuclear fuels. Indeed, if a meltdown occurs, it is possible for the radioactive material to melt through the floor of the reactor vessel and breach the confinement vessel, spreading radioactive material to the earth below a reactor. This is usually prevented by an emergency shutdown procedure. If an emergency occurs, such as an earthquake or other such natural phenomena, then it is imperative that the nuclear reaction is stopped as quickly as possible. If the nuclear reactor is left to generate heat, this will lead to a meltdown and other environmental consequences. In order to shut down a reactor, the control rods must be fully inserted around the fuel rods. In a gravitational system, this happens by allowing the control rods to fall. It is possible to stop the nuclear reactor in other ways, such as removing the moderator, but this allows the nuclear vessel to still be generating highly radioactive material whilst the plant is out of your control, so is not desirable. Once the control rods are fully inserted around the fuel rods, the nuclear reactions can be said to have stopped. However, you still have to control the highly radioactive coolant surrounding the reactor. You need to allow the coolant to cool the reactor over a period of time. This is usually done by pumping the coolant around the vessel and allowing it to heat water and cool slowly. If the pumps moving the coolant around the reactor fail, then the reactor will heat the water uncontrollably, increasing the pressure inside the vessel, leading to a potential breach and leak of radioactive coolant. As I said, nuclear power plants are no more dangerous than regular power plants. It's just that the complication of radioactivity makes an accident a potential disaster.